Hey everybody, we are continuing our logarithm review, and now we are able to use a calculator. So here on number 12, we want to evaluate this expression. So log base 5 of 5. I don't really think I need a calculator for this. What power raises 5 to make 5? The first power does. What power raises 2 to make 2? The first power does. What power raises 6 to make 36? The second power does. So I have 1 plus 1 minus 2, and that is 0. Okay, now if we forget that, we could use the change of base formula. Log base 5 of 5, log of the argument over log of the base. And we should recognize something over itself is 1. And then we have log of the argument over log of the base. Something over itself again is 1. And then we have log argument over log base. And this time we'll use a calculator. So log 36 divided by log 6 is 2. So we get our 1 plus 1 minus 2 equals 0. Next, let's take this exponent, or this coefficient, and make it an exponent, and this one as well. So we have log base 7 of 4 to the third power. So 4 to the third power is 64. And then we have minus log base 7 of 8 to the second power, which is 64. So we have log base 7 of 64 minus log base 7 of 64. That is something minus itself. We should get 0. Next up, solve this equation for x. So we have 40 equals 5 times e to the 2x. So let's divide both sides by 5, and we get 8 equals e to the 2x power. Now, in order to cancel out this e, we could do natural log on both sides. So natural log 8 equals natural log e to the 2x. Okay, natural log is log base e, and that cancels out that e. So we get natural log 8 equals 2x. And then we can divide by 2. Okay, so now natural log 8 divided by 2, 1.04. Next, log base 10, it's a common log, so it's base 10 of 1,000. So this is really saying 10 to the x, 10 to what power equals 1,000. So 10 to what power equals 1,000? Count the zeros. 1, 2, 3. X is 3. Natural log x equals 3. So natural log is log base e. So let's make both sides a base e. So this is e to the natural log x equals e to the third power. And that cancels. So we get x equals e to the third power. So we have second, and then this button right here, e to the x. So we have e to the third power, 20.09. Log x equals 5.44. This is log base 10. So put a base 10 on both sides. Cancel that logarithm. So x equals 10 to the 5.44 power. 10 raised to the 5.44 power is 275,422.8703. And we'll just cut that off at 0.87. Round to 2 decimal places. Natural log x equals 0.2345. Natural log is log base e, so just like we did here, we'll put a base e on both sides. So x equals e to the 0.2345 power. So e to the 0.2345 power, 1.26. Equals 4 times e to the 2x. So we'll divide both sides by 4 and we get 5 equals e to the 2x power. To cancel out that e, let's do natural log on both sides. And that cancels our e. So we have natural log 5 equals 2x. And we can divide both sides by 2, so x is natural log 5 divided by 2. I need to close my parentheses, and I did it divided by 5 instead of 2. So we get 0.8047, so 0.80. All right, next, the population of a town is growing exponentially according to the following equation. P equals P sub 0 times e to the t over 30. P is the population in town. P sub 0 is the initial population. So that's the number of people who were there when we started counting. T is time. And we will round answers to the nearest person because we don't have decimals or fractions of people. We have whole people. If at t equals 3, there are 11,052 people in town, what is P sub 0? Okay, so when time is 3, there's 11,052, so how many people were there when we started keeping track? Okay, so P is 11,052 equals P sub 0, which we don't know, times E, which is a constant term, not a variable, to the t over 30 power, so that's 3 over 30 power. Okay, so we can divide both sides by e to the 3 over 30, which we'll shorten that up as 0.1. It's 1/10 or 0.1. Okay, so we have 11,052 divided by e to the 0.1 power. 10,000.26. So to the nearest person, we had 10,000 people at this time. So P sub 0 is 10,000. So when we started counting, there were 10,000 people. How many were there after 15 years? So we want to know the population after 15 years, now knowing that P sub 0 is 10,000. So P sub 0 times e to the t over 30, so that is 15 over 30. Okay, so now we can just put that in our calculator just as we see it. So 10,000 times e to the 15 over 30, or we could do 1/2 or 0.5 there. And we find that there are 16,487 people in town after 15 years. So the population is 16,487. When will there be 35,000 people in town? So if it continues growing at that same, according to that same formula, when will we have 35,000 people in town? So the population will be 35,000. That equals the initial population, 10,000, times e to the t over 30 power. Now we can divide both sides by 10,000. 35,000 divided by 10,000 is 3.5. So we have 3.5 equals e to the t over 30 power. To cancel out e, let's do natural log on both sides. So natural log 3.5 equals natural log e to the t over 30. And that cancels. So we have natural log 3.5 equals t over 30. And we can multiply both sides by 30. So we get 30 times natural log 3.5. and we find that it's going to be 37.58 years. Now, we were rounding to the nearest whole number previously because that was a number of people. A number of years, we can round that. There is such thing as fractional years. So in about 37.58 years, we should have about 35,000 people in town. Solve this equation for x. The first thing I want to do is condense. There's an addition here, so I'm going to multiply the arguments. So we have log base 3 of 5 times 7, which is 35x, equals 4. Okay, a lot of times people just try to do a base 3 on both sides, but I can only do that when I have a single logarithm. This is not a single logarithm. This is. So we have to condense first. Now we can do a base 3 on both sides. So we get 35x equals 3 to the 4th power. So 3 to the 4th power is 81. And now I can divide. X is 81 over 35, and that does not simplify, so I'll leave it just like that. Okay, once again, I can't just do a base 3. I have log base 3 on both sides. That's great, but I cannot just do a base 3, and I can't just cancel out those logarithms until I have condensed to a single logarithm on both sides. So I have log base 3 of, and because these are subtracted, it will be x plus 2 divided by 2x minus 7 equals log base 3 of 25. Now I can do base 3 on both sides because I have a single logarithm on both sides. So I have x plus 2 over 2x minus 7 equals 25. Now let's multiply this 2x minus 7 over to the other side. So I'm going to multiply this right over here, and I'm going to distribute. So I have x plus 2 equals 25 times 2x, that's 50x, minus 25 times 7, which is minus 175. Okay, so now let's get the x's over to the right and the constants over to the left. So I have 2 plus 175, that's 177, equals 50x minus x, that's 49x. And I can divide, so I get x equals 177 over 49, and that does not simplify. If you can simplify, do so, but this does not simplify. Continuing to solve some equations for x here. So on number 23, I can put this in log form. So I have log base 8.3, that goes down here, log base 8.3 of an argument of 120 equals the exponent x plus 7. Now I can use the change of base formula, log of the argument over log of the base equals x plus 7. So that's log 120 divided by log 8.3, and we have 2.62. We're also going to move this over, so minus 7, and we get negative 4.74. So x is negative 4.74. Here I want to do a base 2/3 on both sides. So I get x is 2/3 to the negative 4 power. Okay, now that is the same as 3/2 to the positive 4 power. If I do the reciprocal, I change that to a positive. So 3 to the 4th power is 81. 2 to the 4th power is 16. Now I could type that in my calculator as a fraction. Okay, so if I want to type in a fraction, math number, all the way to the bottom of the list, so I have 2 over 3, and I want I actually want to put that in parentheses. And I want to raise that to the -4 power. And there I get 81 over 16. Okay, next let's change this to log form. Log base 3 of argument 29 equals exponent x. Change of base formula, log 29 over log 3. Log of the argument over log of the base. Log 29 divided by log 3 is 3.07. Okay, next, before we can do anything with this, let's condense it. So we've got log base 4 of 80, and because it's minus, it's over x plus 2 equals 4. Now base 4 on both sides. So we've got 80 over x plus 2 equals 4 to the 4th power. I'm sorry, that's a 2 there, so that should be a 2. 4 to the 2nd power, which is 16. I'll multiply this over here, so I get 80 equals 16x plus 32, so I distribute it. Subtract, and you get 80 minus 32 is 48 equals 16x. And 48 divided by 16 is 3. Okay, next up, this is log base 10, and I've got a single logarithm, so let's do base 10 on both sides. 5x minus 30 equals 10 squared, 100. Add 30, 5x equals 130. And divide. 5 goes into 100 20 times and into 36 times, so 26. Okay, so here, let's evaluate this log. Log base 5 of 25. What power raises 5 to make 25? The 2nd power does. Or I could do log 25 divided by log 5, and I would get 2. Okay, subtract that 7, we get -5 equals 3x. And divide, so I get x is -5 thirds. Okay, here let's write this in exponent form. X to the 1/3 equals 2. And let's raise both sides to the 3rd power. X to the 1/3 to the 3rd is x to the 1. 2 to the 3rd is 8. So raising to a reciprocal power helps us here. How about log form here? Log base 10 thirds of 67 equals 5x. Okay, so then let's do log of the argument over log of the base. And let's divide both sides by 5. So let's stick a 5 in that denominator. So I have log 67 divided by 5 log 10 over 3. Now I should have put that in parentheses. So I have log 67 divided by 5 log 10 thirds. 0.6980, so that is 0.6984, so that is 0.70.